Welcome to the Explainer. If you're gearing up to build or upgrade a local AI workstation, well, you're in exactly the right place. Today, we're completely reframing how you actually shop for an AI GPU. We're not just going to obsess over raw throughput and tokens per second like everyone else. Instead, we're prioritizing something most guides totally ignore: building a workstation that's actually livable alongside all that raw power. Because, let's be real, blistering speed doesn't mean much if you literally can't stand being in the same room as your machine.
Okay, let's dive right in. We've got a super packed agenda today. We're going to kick things off with the leaf blower problem, establish Rule 1, which is that VRAM is king, reveal the secret to silence, walk through the actual 2026 GPU lineup, and then finish up by comparing open air versus blower coolers. I promise we'll nail down the golden rules of hardware first, giving you the exact framework you need before we get into specific purchasing recommendations. So Section 1, the leaf blower problem, acoustics in AI. Let's just go ahead and address the elephant in the room regarding most of those standard GPU buying guides you see out there.
I really want to ask you directly, does your AI workstation sound like a leaf blower? Or, if you're currently planning a build, do you honestly want a card that benchmarks beautifully but screams like a jet engine while it's sitting right next to you for 8 hours a day? A lot of people end up buying top-tier gaming cards based purely on performance charts, only to realize, oops, they've essentially built a space heater with a built-in siren.
And here's exactly why that happens: 70%. The GPU produces 70%, or sometimes even more, of your total system heat under sustained AI inference. In a local AI rig, the GPU isn't just the heart of the system, it's by far the loudest, hottest component in the box. This really sets the stage for why thermal management isn't just some nice-to-have bonus feature. It's absolutely critical if you're building a daily driver workstation.
All right, moving on to Section 2. Rule 1. VRAM is king, the hard limit. Because before we can even talk about acoustics, we've got to establish the one hard, undeniable limit of local AI. The absolute crucial point here is this: if your model doesn't fit in your video RAM, it physically fails to load and your performance completely collapses. Period. End of story. No amount of raw processing power is going to save a card that's run out of memory. You simply have to pick your VRAM tier first. So looking at the 2026 tiers, 16 gigabytes is your super efficient mid-tier, perfect for running 7 to 34 billion parameter models. 24 gigabytes is really the enthusiast baseline right now. Step up to 32 gigabytes, and that opens up massive 70 billion parameter models without having to rely on offloading. And 96 gigabytes? Well, that's strictly professional territory, designed for those massive 100 billion plus parameter models. Now, you might be looking at those model sizes and wondering, wait, how do they actually fit into those memory tiers? Well, the answer is quantization. Think of this as basically a magic trick for your hardware. Techniques like GGUF, AWQ, or Blackwell's native FP4 are essentially model compression formats, and what they do is stretch every single VRAM tier way further. We're talking cutting your VRAM usage by 50 to 75% with an incredibly tiny, almost unnoticeable loss in quality. It's an absolute game changer, allowing you to run much larger models on significantly more efficient cards. Okay, Section 3, the secret to silence: cooler and power. Now that we've got the foundational rule of VRAM capacity locked in, let's pivot to the how of acoustic bliss. Read this quote with me for a second. The chip doesn't determine how loud your card is. The cooler design and your power settings do. Now, what's really fascinating about this idea is that it totally shifts the blame for noise away from the silicone itself. The exact same GPU chip can be whisper quiet, or it can be ear-piercingly loud. It depends entirely on how you set it up and which specific physical cooler design you decide to buy. And guys, here is your free absolute secret lever. You need to power cap your GPU to 70 to 80%. When you do this, you instantly shed a massive amount of heat. But here's the absolute best part. You do it with almost zero loss in inference speed. Why? Well, because AI inference is generally memory bound, right? Not compute bound. It's waiting on the memory bandwidth, not the actual processor core. So by starving the core of just 20% of its power, you drop those temperatures dramatically while keeping your tokens flowing just as fast. Seriously, this is your first and most impactful move. Let's jump into Section 4, the 2026 GPU lineup. Find your best fit. It's time to take all these rules we just talked about and apply them to the actual hardware matrix for 2026, so you can systematically self-identify the absolute best card for your specific setup. Notice how this hardware matrix is laid out. It's not just organized by the name of the card, but critically by VRAM and power draw. By evaluating these metrics side by side, you can perfectly match your required VRAM, which again is based on the models you actually want to run, directly against your power constraints and your budget limits. Let's break these down one by one. Up at the very top, we have the RTX 5090. Look, this is the best overall consumer GPU for local AI in 2026, full stop. It gives you 32 gigabytes of VRAM and a frankly mind-blowing 1.79 terabytes per second of memory bandwidth. But yeah, you probably noticed it draws a staggering 575 watts. So how do we reconcile that insane heat generation with our goal of a nice quiet room? By doing exactly what we just learned. You apply a 70% power cap. That single tweak tames this heat champion and makes it perfectly livable for daily work. Next up is your 24 gigabyte baseline. The RTX 4090 is a proven, reliable enthusiast standard. And honestly, it runs cooler out of the box simply because it draws 450 watts compared to the 590's massive draw. But if we're talking pure value, picking up a used RTX 3090 is an incredible move. It gives you that exact same 24 gigabytes of VRAM, but at a fraction of the price. The catch? Well, it's older silicone, it's less efficient, and it definitely runs warmer per token. So if you go the used 3090 route, that power capping trick we talked about is absolutely mandatory to keep the noise down. Now, if you only really need to run 7 to 34 billion parameter models, look no further than the 16 GB options, the RTX 5080, or even the older 4060 Ti. These cards are the absolute efficiency sweet spot. Seriously, this is your easiest, most straightforward path to a cool, quiet rig simply because they produce meaningfully lower power draw right out of the box. And as we know, less power equals less heat, which naturally equals slower, much quieter fans. Finally, let's talk about the true heavyweights, the RTX Pro 6000 Blackwell. This is the very first professional card bringing 96 gigabytes of high-speed memory straight to retail. Now, at roughly $8,500, yes, this is a massive professional step up. But crucially, this thing is specifically engineered to run flat out, continuously, in super dense multi-card builds. It's literally built for sustained operation without melting down your entire system. All right, moving to Section 5, open air versus blower coolers. Pick your cooler. This final hardware decision is definitely not just an afterthought. It literally dictates your entire acoustic reality. So there are two completely opposing build strategies here. If you're building a single GPU rig, you want a large open-air cooler with triple fans. Why? Because with plenty of room to breathe, it spreads the heat across a massive fin stack really quietly. But actually scratch that if you're building a multi-GPU rig. In a dense setup, open-air cards will literally suffocate each other, breathing in each other's hot exhaust until the fans just roar. For those dense, stacked rigs, you absolutely must use blower-style cards that forcefully exhaust that heat right out the back of the case. Let's wrap this up and summarize your actual buying funnel. Step 1. Pick your VRAM tier based on the models you actually want to run. Please, whatever you do, do not base your purchase on raw gaming benchmarks. Step 2. Optimize for quiet by planning a smart power cap and picking the right cooler type for your specific case. And Step 3. Handle the rest of the system. Grab a high airflow mesh case, get some quality case fans, and maybe consider fresh thermal paste if you're buying a used card. I want to leave you with one final, kind of provocative thought before we go. We've talked a whole lot about mitigating GPU heat today, but if absolute silence matters to you more than raw throughput, are you willing to sidestep the heat entirely? Because Apple's silicon, with its unified memory architecture, offers a fundamentally different acoustic trade-off. We're talking no massive power draws, almost zero fan noise, just massive memory capacity. It's a completely different world of local AI, and it's definitely something worth pondering for your next build. Thanks for joining me on this explainer, and hey, happy building.